I'm going to introduce Lantao Wong. So Mr. Lantao Wong from Stratasys. He's also going to talk on 3D printing. So welcome. Thank you.
Good morning, everyone. And I'm Lantao Wang from Stratasys, China. I'm the pre-sales and application manager. So today I will focus on our company introduction and our product, and also the mainly application used in the food and beverage industry. Basically, we are a merged company from US and Israel. We have two headquarters in US in Minnesota, and another headquarters in Israel, Rehoboth. These two companies was merged by the end of 2013. And currently we have more than 2,200 employees globally. Then we have over 260 resellers in the whole world. And currently we hold more than 500 patents for the 3D printing, and we have more than 35,000 units installed all over the world. And basically we have three technologies. One was PolyJet. This is we use photopolymers, and it's basically from Israel. And FDM is fused deposition modeling, is from US, and SolidScape also from US. So this is the award that we got in the past years. There's so many awards from almost all the industries. So let me introduce the PolyJet technology. Actually, this technology is just like the traditional 2D printer. We use the photopolymer, then use the UV to get the liquid to be solid. Another technology was the FDM. FDM, we use the real thermoplastic. Then it can get so many. Currently, we have 11 materials can be used, like PC, ABS, or nylon. And we use this technology. We can do very accurate parts and very endure parts. So basically, for the product series, we have three different parts. One was the concept modeling. That's for the design engineer, they have new ideas. They will design their models. Then they need to come into real life. So they use this kind of printers to produce the real parts. Then the second one was the prototyping. Prototyping is very popular for for R&D to speed up the R&D process to save cost and money. And a third one was we call the end user parts. Sorry. The end user parts that produced by our printers, it's mainly for the end use. I mean, after printing, these parts can be used directly For example, for NASA, we have some parts that can be produced by printer directly used. Here, I'd like to thank Jeffrey because he used our machine in his PPT. So it's a really famous machine. So this was our idea series. Basically, it can realize the designer's idea into real life. It's not only just pictures or 3D data. It can just several hours can change their can make their idea into real product. So they can show their ideas to customers, show their new designs. And this series we call the design series. Design series it's really for manufacturing or for the factory production, because every factory they have R&D department. They need to save time, to save money, then to get the new product come into market in a short time. But we can help them with these machines. The third one we call the production series. Also we call the DDM. It's direct digital manufacturing. Actually, like NASA or some other customers from defense, they use our machine to produce the end user parts. Actually, these machines is made by ourselves, but we have 47 parts inside was made by other machines. Because this big one, we don't have so much production, maybe just less than 100 per year. So we use the other printers to print some parts installed in the big machines. It's really save time and save cost. So basically, our 3D printing widely used in these industries. So it's almost I mean in all the industries we have successful case. So here I will introduce what we can do for the food and packaging industry. Usually we can printing the mold for packaging. So this is the production from the inkjet molding. Then we can produce the mold. Because the traditional molding, they use CNC to manufacturing or use the other machines to get the metal mold, but maybe take long leading time. But for us, if you finish your design, you just take several hours printing, you finish this ABS-like molding. So you can printing these parts immediately. So it's really reduced the cost and time. And for the bottles, for beverage, we can also make the mold. So for the designers, they can change their designs very quick for different bottles, different shape, and for different customers. They made this mold in several hours, then put into inkjet molding. So they will got the bottles very quick. Then after they finalize and the customer say this is what we want, so they will change this. We call the plastic molding into metal molding. Then they can do the mass production immediately. So this is the basic idea for the bottle manufacturing. So they use the very hot air from the hose to inject to the mold. We call the parison. It's a kind of plastic tube. Then because it's hot, it explode the plastic. Then it shape the bottles. So here, what we can do, we can supporting or give our customers very quick models for new design or new ideas. So for customers, they can very quick to be put into production. So this one also our printing models. Then these was the bottles that customers usually used. So it's very personalized, or it's very flexible design for the manufacturer. Also, we can printing something like transparent, very clear bottles like this. So even it's printed, but it still can be very good seal. You can see the water was inside, and we have rubber to seal together. It's really 3D printed. And this one was a kind of bowl. It's with we call the tangle. It's something like rubber, and this one was the rigid bottle. So it can be sealed very nice, and you can put the liquid inside and test and see if this one was good for the market. And this one was our new materials. We call the RGD 450. It's more cheaper and very nice surface. You can see it, and it's mainly for like our soap. You can put it in and then just use it, because the designers will have more ideas every day, so they can print it in several hours, then to show to the market if this one was good to be mass production. This one was also the same. So here we have some case study from different customers. This is IKEA. They use our machine to printing the cups. It's very nice, and it's very quick design for them. This customer was mainly for cosmetics packaging, and they made different bottles. For ladies, they like cosmetics to be very shining profile. So they designed the different models, then they print it by themselves. It's no need to be outsourcing, waiting for time. Then it's really save their cost. So this one was from Trivia. The left picture was their design, and we printing the models for them like this. But this one was after polishing and painting. And this case was from Coolgear. They are the cups manufacturing. So they have different design here, and after design they use our printer to print it, and then painting with different colors. Then finally they will show to the fair or show to the customers if this one was good for you. And here you can see the time saving and cost saving. This case was from Nestle. So basically they made a coffee a container holder to be put like this. It's very new design, and it's very successful case. And this customer was from Japan. They also made the cups. It's very nice cup they made, and they have manufactured in both Japan and China. And they use our printers to printing the prototyping, then released to the market. Okay, that's all. Any questions?
Another one from Jeff.
The cost of 3D printers have come down significantly since the patent was released recently, and since the over the last year we've seen them reduce the smaller types and larger types all come down in cost. Is that a trend that's going to continue significantly over the next few years, that the actual cost of the printers will reduce? And if not, what are the sticking points to allow for further cost reduction of the machines?
Actually, the 3D printing is not used for mass production. It just can reduce your R&D time and leading time to the market.
Oh, the price of the machines, do you see that they will come down?
Yes, I think so. Because we have so many competitors and the technology will be mature eventually, then the printing cost will be down, sure. I think it's not only the hardware, because also the materials, the cost will be down. Yeah. Because in the very beginning, we put a lot of money on R&D for the new materials. It's more than 100 of different materials. We need to do almost all the tests for MSDS, to show our materials property. Then after that, we will get the cost down for sure. Thank you.
Thank you. One more question.
There are 3 types machines, right? There's 3 series, right?
Yes.
What are the difference between these 3 types of series, and what is the cost index or price index between these 3 series?
For the design, for the idea series, basically it's small, and you can use in your office. The idea was just you have designers, they have new ideas, they will change their design to real one. So that's the price. It could be $10,000 US. That kind of level. For design series, it's something like you can call it. It's a tool to speed up your R&D process. Usually the price is between $20,000 US to maybe $100,000 US. And for the end use, for the production series, it's more expensive, something like $500,000 above. Yeah, because the machine can produce the real end use parts, so it's really reduce your molding cost and reduce your time. So it can be used directly. So it's compared to traditional manufacturing like CNC or like we call the reducing materials manufacturing. It's the cost was good enough to buy it and to use it.
Oh, one more question behind there, over there. Thank you.
Actually, I want to ask, when you provide or sell the 3D printers, you also sell the materials for that printer, right?
Yes, like HP or Canon.
Okay.
Yeah, we provide, we call the hardware, so that's the machine.
Yeah.
And also the software, and also the materials, and also the solutions.
Okay.
So, yeah.
The second question is how many materials you can use for your today's 3D printers?
We can say that we have more than 600 materials could be used for our machines, because we have 2 different technologies. But for each of customers, they don't buy all of them, because they don't use all of them. They maybe just use one of several,
Okay.
several materials.
Okay, so all these materials basically is plastic based, right? Or you also have a different group of the material that also possible?
I think for the materials you can use only provided by our company. This is the first one.
Yeah.
And we have two different technologies. For PolyJet technology, it's the materials was liquid. It's a photopolymer.
Yeah, it's liquid format of the plastic.
Yeah,
right?
but after finish printing finish, it's solid.
Solid.
Yeah, it's solid. It's we call the PP-like. Yeah. And for FDM, it's really thermoplastic. 你如果不清楚，我可以给你讲中文，不好意思。
我就想大概知道你们的这个 material 的种类，因为是不是主要是塑料为主的，就是
对，我们主要是塑料为主，然后我们就是一个是热缩性的工程塑料，
OK
那个大概有11种是 FDM 这边的技术，然后如果是光敏树脂这边的技术，我们大概目前现在有可以混合到600多种材料出来。就是我们已经有数据表的，可以提供给大家用的材料是600多种，但是对于特定的行业或者特定的客户来讲，他可能只需要买几种就够了。
对。I didn't know that.
OK， 可能有些人会 ，Sorry，I just want to say something more.
Yeah.
可能有些人会问说，你们的机器可以打印实物吗？很抱歉，目前我们公司提供的打印机不能打印实物，可能将来会有。将来会有。
我想提一个问题，就是你这个，比如说这种塑料，你在打印的时候，是不是会产生污染？
目前我们拿到的报告就是说，我们的设备是可以放在办公环境下使用的。有一些就是可溶性的支撑，就是 FDM 这边技术的那个，就是后处理的一个过程是有一定的这个污染的。但是我们有一个报告，就是说你可以通过一些后处理，然后变成一个中性的溶液，把它排放掉就可以了。
那这个排放的设备，你们
这个我们都有提供，包括解决方案我们都有。因为我们这个设备在美国，包括欧洲跟日本，我们已经用了大概有接近20年的历史，所以特别是在日本跟欧美，它的对环保的要求是非常严格的。
那就是它应该有专门的空间去处理这些事情。
对的，对的，我们都有解决方案，确保您在使用中就是说没有后顾之忧。
谢谢。
谢谢。
Okay, thank you very much.
Yeah,
That was very
thank you.
interesting. Definitely a great tool for innovation. I think there will be a continuing interest in that technology. Now I'm just going to try and move on to the next one, which is